Thank you. Okay, I think, yeah, we'll quickly get started because I think we already lost 5 minutes, but yeah, we'll make up for it. Hello, everyone. This is Maneesh Rawat. I know it's a bit of nap hour, but I'll try to keep it entertaining and engaging. So yeah, today I'm here with my colleague Bakul. We are from Tessell, startup in the database world. You'll hear about us more as we grow further. But today we are presenting here a specific topic on how do you Nitro boost your Postgres workloads. Nitro boost, as the word itself suggests, it's more about getting high performance. How do you get a database infrastructure which is highly performant? So we'll talk about the needs. Why do you actually need that, and how can you do that, and how Tessell is also doing that on those kind of things. Nitro in Bangalore might cite a very ironic word, right? Looking at the traffic, you don't see this kind of thing anywhere. But yeah, at least what we can do in the technology-wise, let's solve that problem if not on Bangalore roads. Moving ahead, we have all seen how Postgres is growing as a choice of database across the world, right? Across the enterprises, across the industries, across various verticals. According to various sources, it is now the second most popular database engine, used by more 100,000 plus companies across the globe. And this is the trend you see, how it's been growing. 315, the popularity score, which has reached almost double by 2022, which is a score of 618. What does this mean? Let's also talk about what kind of systems are today using, using Postgres. We have seen in primitive world, pre 2015, 2014, Postgres was still considered to be a more an experimental kind of database, right? We heard from from Zerodha also in the morning that very rarely any enterprise workloads were moving to Postgres. But today, as you compare the situation, I can give you a trivia that a bank like ICICI Bank is actually running their UPI database on Postgres. I work with them. Ola is running their Postgres workloads, which gets data from their thousands of cabs into the system on Postgres. Instagram is using Postgres for various workloads, and similar to Reddit. What I want to emphasize on the fact is that all these customers who are using Postgres for their enterprise workloads is making Postgres more and more performance hungry, right? The database is good, the car is good, but can I get a good road to run this car, right? That's the concept, or that's the problem we are trying to solve here. We all know AWS, Azure, the clouds RDS have tried to solve this problem in some manner. We all must be aware, whoever uses AWS at least for Postgres must be aware there is something called IOPS meter or provisioned IOPS. You create Aurora, you create AWS RDS, you get a bare minimum IOPS with it, but as you need more, you have to pay for it, right? So it's like paying a much higher toll tax to use a good road. For example, for a 20,000 IOPS, I have to pay $3,000. For 40,000, $5,000, and so on and so forth. And more than that, Aurora is also a highly performant system, but 90% of the cost on Aurora is in fact IOPS, right? Much more even than an RDS system. If you compare, a 60,000 IOPS system will put you back by $32K per month, or an 80,000 IOPS system will put you back by 43,000. Are we willing to pay that kind of cost to achieve this performance? Can someone do it for me in a much easier, much cheaper way? Let's see. So this is again an explanation how 80,000 IOPS for a R52X large system with a 8 vCPU, 64 GB, which is an average workload output, not a very high workload also, with a 1 TB of storage can cost you just the IOPS cost around $43,000. Moving ahead, there's also a system in AWS which can give you up to 200,000 IOPS. There is a limit on most of the shapes, up to 80,000. But there is a system which can give you 200,000 IOPS. But that will again set you back a big time in terms of cost. Can someone do it for a much lesser cost to us, right? This is where Tessell plays a role. Tessell plays a picture, comes as a player for you, who can do this, give you same kind of performance, same kind of compute, with much higher IOPS rate, which is 200,000 IOPS for a $3,000, right? So our proposal here, or our USP here, is a price versus performance thing. We are able to give you this performance at a much, much, much lower cost. And this is how you give it, right? We are using these machines as an example. i4i.2x large, who has worked in AWS, must be aware of these machines. So you get same kind of compute what you get in RDS. You get an 8 vCPU machine with a 64 GB of RAM. 1 TB of local NVMe storage. I'll go into deep more how we achieve this. But this can be achieved with a $3,000 per month expense. Same kind of performance with a much, much lower toll tax, if I may say so. Let's see how do we do that. Each of the clouds have two kind of shapes which they have to offer. One is a typical shape, a standard shape, what we call it in Tessell terms, where you get your EBS storage or a cloud storage attached to it. It brings flexibility to you, but there is network latency because whatever you say, this storage is on a network, right? And that's where an IOPS meter starts. If you want more performance for this storage, not only you pay for the actual storage, for example, a 1 TB storage will cost you something, the more performance you need from this storage is what builds your bill, right? This is where you get into a cycle of paying more and more as you need more kinds of performance. On the other hand, clouds also offer shape, all the clouds in fact. For example, AWS has these shapes called i3 instances or an i4 instance, the next gen of those. On the similar lines, Azure also has these shapes called standard LSV3, right? Which are in terms sometimes also called bare metal shapes. But the advantage of these shapes or the characteristic of these shapes is that they come with local NVMe storage. What does that mean? It gives us two kind of advantages. One is it comes with inbuilt high IOPS. For example, if I take again a 8 vCPU 64 GB machine, it already comes inbuilt with a 200,000 IOPS without any IOPS meter cost associated with it. Not just that, because this storage is embedded in the compute and storage is locally connected, there is literally zero latency between these two when communicating, right? When a CPU is writing some data into the I/O disk or performing an I/O on the disk, the latency is literally zero. And I am not saying this. This is a quote which you see here picked up from AWS page. They themselves say that these instances are a great fit for databases such as MySQL, Oracle, MS SQL, Postgres, NoSQL, because of their low latency local NVMe storage, which is needed to meet your application requirements, right? But then the question arises, why is no one using them, right? Why is there is no RDS available, right? If it's a product of AWS or a product of Azure, there is no Azure Postgres service on these shapes also. Let's talk about those. Why is it not available? These are the three reasons. First and foremost, there is no data permanence on these systems. The storage, the local storage which I'm talking about, is actually ephemeral in nature. You shut down the machine from AWS console, you will lose the data. Sounds very dangerous, and that it might burn off your hands. But this is a problem which talk about how Tessell is solving, or as an individual, as a Postgres developer, you can also solve it. No management layer, as I said, nobody today offers RDS or a management service or managed service of databases on these shapes. If I have to do everything on these shapes, first of all, I need to be worried about data protection. Is there a player in the market who can provide me a managed service on these instances? We'll talk about that. And no choice of cloud, right? Once you have these shapes, this like an i4 shape, it's only in AWS. Can I get your technology which runs managed services irrespective of the cloud? Can I run my data managed services in an AWS local NV machine, a Azure local NV machine, or a GCP local NV machine, right? So these are the three challenges, predominant challenges I would say, which someone can face. Although a machine is available for you, it is not suited direct usage for your data. Like a lot of customers use them, but these are for very temporary workloads. I know customers who use these machines for running some kind of ETL jobs, right? They load the data once, they run their jobs, and then they get rid of it. But why can't I run a relational database on it, right? Can someone give me data permanence on it? Can someone give me managed SQL service on this? Let's move ahead. Tessell has a technology which is patented right now, using which we can bring durability to this high performance local storage. What I mean by that is, Tessell will guarantee that the storage or the data which is on this storage is a zero data loss infrastructure. We have developed a software layer on top of it, which basically works on the concept of data syncing between your local and a EBS storage. I'll talk about how it still saves the cost. Let's take an example, the expensive way or the Amazon RDS way. For a 80,000 IOPS, you will have a 24 hours per day EBS utilization, the attached storage which you'll have which is 730 hours a month. And the IOPS cost on that will be around $8,000 per month, okay, which is a 80,000 IOPS machine. Let's see how Tessell solves it, or other technology which we are talking about can solve it. So this is your primary storage, which is the local storage, which runs, the machine cost is literally nothing without the IOPS. It's around $500 per month. We have a technology called Tessell Adaptive Sync, which we also called a TSM layer or Tessell Storage Management Layer, or using which we have made this local storage snapshotable. What this means is the clouds provide a technology for you to snapshot EBS storage, or Azure provides snapshotting of Azure storage. What we have done here is we have developed a software layer which works exactly how you would actually behave, or snapshot technology would behave on a EBS storage. What this means is, for you, it's transparent that the database is running on a local storage. You just enjoy the IOPS, you enjoy the high performance. At the same time, you also get data protection for your databases. We will be able to give you, and the output of this whole layer is nothing new. It's the same snap. All tech developers here, I know you should have seen how a snapshot ID looks, right? Snap hyphen some random digit. The snapshot output which you get from here is exactly a cloud resource ID. And using that, you can again clone and create volumes and create more copies. So nothing changes from the consumer perspective. The consumption of the whole snapshot is exactly same what you do in cloud. If you run this technology in Azure, you will get an Azure snapshot as an output, like the whole resource URL. If you run this technology in AWS, you will get the snap ID as the output. And then any operation which you would usually do on a snapshot in AWS or Azure, you'll be able to do exactly same operations on everything. How do we do that? On the right-hand side, you see here our technology. The first camera is nothing but, so what we do is we have an EBS storage disk which keeps coming, and which comes to this machine, takes a snapshot, and then goes back. When I say take a snapshot, it basically has an untimed technology. I'm not going to deep into it, but it's more of a data block sync from your EBS, from your local NVMe disk to this EBS storage. So instead of running this EBS storage of 80,000 IOPS for 24 hours, Tessell needs to run only it for 1 hour, okay? And that's what, so whenever a snapshot is taken, and it could be a scheduled snapshot, or you as a user can decide when do I want to take a snapshot of this machine or this database running on this machine. So this disk comes for an hour, syncs the data blocks, and it doesn't mean that the database is stopped at that time. The technology is such that the write and read from the database keeps happening, and the delta block sync keeps happening to the EBS storage in the write, okay? And at a certain point when the storage is given or the data linking completed, we take a snapshot of that EBS storage, which you see here on the right-hand side. So this comes, you sync the data blocks, we take a snapshot, and that becomes a snapshot. Now the question could be, what about when this disk is not there? How do I protect the data? That's where our transaction logs, for example, Postgres, the wall logs come into picture. And again, this technology is application agnostic. This is a storage layer technology which we are talking about. So obviously Postgres could be one consumer, but we can talk about any application in the world which needs this kind of performance and data protection. So the whole technology is totally database or an application agnostic. It runs on the storage layer completely. And that's what keeps happening again and again. The EBS just comes again, you take a new snapshot, and the gap is being filled by the transaction logs. So anytime you want to recover your database, a snapshot or base snapshot will be used, which is nothing but an EBS snapshot. And on top of that, you can apply your transaction logs, whole thing. And that's how your data protection is complete. You don't have to worry about what if my machine goes down, what if my crash happens, any of these things, okay? So this is the whole process which keeps happening. A EBS snapshot come, transaction logs keeps happening in the background. There's a lot of automation involved. I might be trying to explain it in very, very easy terms, but this is on high level how the technology works, okay? So yeah, sorry, go ahead. Sorry? Recovery point object. Recovery point object will be 0 in this, because what we do is, it's not just the snapshots, the transaction logs are coming, and we have also found a way to multiplex this of wall logs onto a durable storage also, okay? Yes? Not the replicant for now, yeah. So what we also do is we do data blocks of this wall sync also on a durable storage. The way EBS storage is coming, because 80,000 IOPS disk is coming again and again, but is also durable storage in S3 where these things are good, data blocks are being synced up. Sorry? Everything, they can, everything. But we don't have it a very, very high IOPS. You don't have to have that, yeah. Sorry, yeah. So this is how the whole technology works. This is some performance benchmark numbers. We have obviously done slope kind of benchmarks and everything, and this is what we have seen. We are seeing around, and this is the Postgres workload which we ran on one of these shapes. We're able to achieve 1,200 TPS, or transaction per second of workload. And in terms of IOPS, I have to see, I'm able to achieve almost 165,000 on a 200,000 IOPS. So this is a 200,000 IOPS machine. But from a database perspective, it is able to consume or able to retrieve around 165,000 or 165K IOPS, right, without paying any IOPS meter costs. So this is what you can achieve using this. I also have a slide on actual benchmark comparison with a similar shape on AWS RDS. If you run a similar workload on RDS shape of 8 vCPU, 64 GB RAM with a 22,000 IOPS. Why 22,000 IOPS? Because I've tried to keep the cost same. For example, if a Tessell compute or a Tessell RDS costs $3,100 or $3,088 per month, what do I get in RDS for that, right? So on RDS, I get this machine with 22,000 provision IOPS, and you can see, I know it's a Postgres conference, but no harm in showing how other things also can consume. As I said, it's a application agnostic technology. So yeah, you will be able to achieve these kind of, so again, you're seeing on RDS, we will be getting tested in terms of Postgres around 36,000 IOPS, but in terms of RDS, we were able to, in terms of Tessell, you were able to get a 165K kind of IOPS. And again, these are repeatable and verifiable benchmarks. Any one of you want to try it, please come to the booth. We have, a free trial system. We can give you a login. You can create your own systems and try this whole thing. I really encourage for you to do that. Sorry. So yeah, so each compute you're right. Each compute comes with a specific data set size. For example, a 8 vCPU machine comes with a 1 terabyte. What we can also offer is that it has to be a balance between what kind of IOPS you're looking. It could be a hybrid storage then, where we can attach. If you don't want to increase your compute size, a CPU and RAM side, but just the storage, then you'll have to attach a EBS storage and then balance out. But in case you're okay to go with the higher higher CPU and RAM numbers also, then we just bump up the whole machine to a higher vCPU number. So there you're right. Because the storage comes embedded in the local storage comes in with it. Go ahead.
Just one thing I'll add. Yes, it comes in discrete jumps, but even for the let's say same 8 vCPU shape, the good thing about clouds is even AWS realizes you need many options. So just for 8 vCPU, you have 4 options. So there are discrete jumps. So you can have go anywhere from 1 terabyte to 4 terabytes. Right? Yeah, there will be discrete jumps, but you have a lot more options. Yeah.
Something to spill over.
Yes. So we're working on a solution for that as well, because what happens is generally you fall within a certain range, right? And over a period of time, your data grows a little bit predictably. When you're growing, and then you look at the database, what do you contain? Is it a lot of archival data, old data you're storing for a long time, and why do you want to pay premium storage for that? We're working on a hybrid solution for that as well, where you can put your near recent data on the high performance, and you can move your older archive data on the hybrid low performance.
Something like a data life cycle.
Yeah, so then you can scale it. Don't have to be restricted to those discrete jumps. But you can
basically you're trying to build some kind of a use it as a tiering, and then the older data to the later different tier basically.
Yeah, you can move to tiers, or you can make it we can even make it continuous. So you can scale, add more storage, because if it's a hybrid solution, right? You can add.
Thank you.
Thank you. Thanks, Pakul. Thanks. Sorry, Ken.
The snapshots that you're taking, is it getting replaced every time, or it is the older snapshots are also getting backed up somehow?
So this whole thing can be policy based. You can decide as a consumer of the database how many days of SLA you want to set. Maybe you want to keep 7 days of snapshots or 10 days of snapshots. Everything is policy defined, and we can keep them forever for you. Tessell also has a lot of other features, which I'll talk about in a different session. For example, we have feature of converting these snapshots to actual PG dumps and storing them for archival and everything. But as snapshots, as you said, these snapshots are typical delta snapshots with whatever data is changing, and then you can store them for as many days or as many weeks or years if you want. There's no restriction on as such.
So if the instance really goes down, how much is the recovery time to build it from the transaction log and the last snapshot?
So it depends on how many transactions and how far the snapshot was, right? For example, if it was very close to a snapshot, then the snapshot recovery time is almost instance. But the archival or the wall log apply time can totally depend on how many logs are there and how many transactions were in part of that. It can totally depend on that. Sorry? Every 5 minutes, in fact. The wall logs backups we are taking every 5 minutes. But when you do a recovery, for example, we have a point-in-time recovery functionality from our console. So what you get, whatever point in time you choose, we applied at runtime whatever logs are required to reach up to that point in time.
Hi. Okay. So how?
Sorry, go ahead. Go.
Okay, I have one question. Like how Tessell is different than rsync command in Unix? Like we do file system sync. So how Tessell is different?
So the technology underlying is different. What we do is, I can tell you the internals. There's a library called DatoBD, which we have is open source, which we have modified and patented to do this kind of thing. So it tracks a lot of delta blocks and lot of delta things are happening in the background.
I think does the same at OS level. It syncs the blocks only. So how come it is different? I just wanted to understand in internal way, like how it is different than rsync, because
rsync.
it is already there.
I
And we
understand,
can use the same for the same purpose that you defined here. We can use the same technology for that. You don't have to go for Tessell or something else, right?
Yeah, I understand. So what I know in detail, I don't know it too much in detail too, to be honest. I can connect with the engineering who's done it. But I know that internally they use DatoBD, which is a library which keeps track of a lot of delta blocks in a very efficient manner. That's answer for me. I can connect you with my engineer after the session. We have a booth there and we can get more details. Yeah. Go ahead, you had to go. Oh, same question. Okay, yeah. I'll continue then. So this is the performance comparison which I wanted to show you in terms of actuals, right? IOPS, what the infrastructure provides is a very file system kind of thing. But what does it mean when I run a Postgres database on it? What kind of consumption can a database does on it? So these are the kind of numbers you can see. We ran the exact same workload on a machine which costs $3,000 on Tessell and RDS, and this is the number we were able to get. Quickly, I will show a quick demo. There's a second part of the whole thing which Bakul will take care. But I know it's a tech conference, so I wanted to mostly, it would be okay, I thought, to show a black screen and I would say a terminal. What I've done here is, let me log into two machines. This is one of my PG servers. I would also like to show you, this is the Tessell console, which Bakul will talk about in detail. This is one of the machines which I've kept and created, which is a Tessell 8HA. And there's a Postgres server running on it. So let me run. What I want to show you is basically a IOStat. Okay, I'm not able to type. Okay, there's a lot of lag. Hold on. That's the Wi-Fi. Okay, sorry. So I'm going to run an IOStat to, right now there's no workload running. This is the other one which I down you see is a PG client. I'm going to run a workload on this IOPS machine or the high IOPS machine. Let me go there. A typical PGIO slob workload. And just let you see on your own what kind of, TPS you can get, right? You see it's going up to 1,100,000, 112,000, 130,000. So this is the kind, and this is a database IOPS, not just the machine IOPS, right? This workload, it's I think at a 15% write and 85% read, but you can obviously adjust how you want. But this is the kind of performance you can get from this machine when you run, especially for application which are IOPS hungry, like a UPI system or anything, any for that matter, right? Any higher number of transactions hitting the system. We have a customer in US, Lightning eMotors, who's basically a Tesla for trucks, right? They have tons of trucks running and sending data to these systems running on Tessell. And that is able to handle these systems. This kind of systems are able to handle their system. So you see, it continuously gives a performance of 128K, 130K, a live system which is running here. Okay. So yeah, this is what I wanted to talk about majorly in terms of Nitro Boost. What I also have a second part, which my colleague Bakul will take over. Thank you.
This is in slideshow mode, right? Okay. So what Maneesh showed you was how can you build a Ferrari-like engine in a cost-effective manner, right? But if I give you an engine, what will you do with it? You need a car, you need all the features, power windows, and AC and everything. And that will answer your question as well, like why Tessell? What he showed you was a beautiful differentiated infrastructure, data infrastructure. We've taken a bare infrastructure, made it into a cloud-like durable data infrastructure. But not just that, we use it to give a highly differentiated database as a service. Okay, and not just database, but or not? Okay, sorry. Yeah, it's a fully managed DBaaS. That's what we have built. So what do we offer? What do we have to offer? Number one, provisioning. To be able to give you choice of cloud. You can do this on AWS and Azure, as Manish was saying. Choice of compute. We saw high performance compute, which can give you a lot of IOPS. You can also use standard compute shapes where if you might have some secondary workloads, you don't need high performance. You can use that as well. So instantly, within minutes, you can spin up a database on your choice of database. Postgres, MySQL, Oracle, SQL Server, anything. Okay. So provisioning is fully taken care of, fully automated. What's next? Patching. One of the most dreaded jobs in database management, right? When you have, as you grow, your databases grow. They become mission critical. You need to patch them without any downtime. So patching is fully taken care of, fully automated. You said you're talking about RPO and RTO, all those things, right? Whenever there is a question of RPO, RTO, when you have mission critical databases, we recommend you do a multi-AZ HA service. So that way, both of them are minimized, right? One of the beautiful things we have with a multi-AZ HA is the replica that you get, the standby instance you get as part of multi-AZ HA, that's readable. So typically you go to a cloud service, you get a multi-AZ HA, the standby is not readable. You're paying insurance premium on it, but you're not able to use it. With Tessell you can, right? So you don't have to create an additional read replica. You can, but you don't have to, right? And that also minimizes your RTO. RPO is anyway 0, but you minimize your RTO as well if one instance goes down. And that's what the last point says, near 0 downtime for HA services because it's a patching, rolling patching. We talked about multi-AZ HA, but one of the big differentiations that we offer is a cross-region DR, right? One of the requirements for many companies these days, especially in some compliance regulated sectors, or even if you are a company you want to go IPO, one of the ISO requirements is you need to be BCP compliant. What that means is, if your data center goes down, basically a region goes down. We have been seeing that quite often. Sometimes an entire AWS region goes down. What happens to your application? What happens to your data? Is it still running, right? With Tessell, you can create a cross-region DR, and you will be able to, in a click of a button, you can test failover, switchovers. You can do DR drills as part of compliance, right? So we offer full BCP compliance for your mission-critical databases. As any other managed service, it comes with full-fledged monitoring. With all, it's always we guarantee the uptime SLA. Right, you get comprehensive monitoring metrics, top SQL queries. You can debug if any query is running slow. All those things. Manish talked about something about backups, so I'll spend some time here. You can take snapshots today, right, on any cloud, any service you want, but that's a lock-in, right? It's a cloud lock-in, vendor lock-in, all those things. With Tessell, we believe you should not be logged in at all. You can take snapshots. Tessell takes snapshots. You can take manual snapshot as well, but we don't want you to be logged into either the cloud or the vendor. You can convert snapshots into backups. The keyword here being convert. Does not impact the database. We can take a snapshot and say take this and convert this into a native backup. So with Postgres, you can get a PG backup using PG backrest or any technology you prefer. You can take that backup and you can use it wherever you want. Right? So tomorrow if you decide, okay, I used Tessell, I didn't like it, I want to move out, we give you the backup, gift wrap it to you, and you can use it wherever you want. Right? This is another beautiful feature where many companies need it, especially when you are sharing data. These days data has become very sensitive. You have all the companies have some sensitive data. Every company will have it. And you talk about data sharing, the moment you talk about it, you get frowned upon. Oh, how can you share data? It's sensitive. But if you don't share data, if you don't give good quality data to your developers and QA team, then the testing is flawed, right? You want to give them good quality prod-like data. How do you share that? How do you make it available to them? You would probably build your own tools or use siloed apps. With Tessell, it's a built-in feature. It's a built-in app of masking. You can just bring your script, upload it, and that's it. Tessell can give you a masked copy, a sanitized copy of your snapshot, and you can use it for later purpose. It will catalog it for you. It will store it for you. You can use it. You can share it with developers. There's an app called Availability Machine in Tessell where you can decide who gets access to data, where does he or she get access. You can pick a region, and you can pick what kind of data. Is it as-is data, sanitized data, not just sanitized data, but even data dumps. You can create policies around it, right? So it's very secure, controlled way of data sharing. That's what we like to call a walled garden experience for your engineering team. Sorry? Not directly from the snapshots, but you can materialize them, right? And today you have to create a clone, so that's the next thing. You can pick, you can create a clone or restore the database to any point in time using a snapshot or PIT recovery as per the SLA, and you can use that for querying. Another app that we have built is Dataflix, inspired by Netflix. Basically, we want to be the Netflix for enterprise data, right? The way you consume content on Netflix, same way you can browse data here. And the vision for Dataflix is to open that up for business users, the way you are saying, right? Today, it's more of dev QA centric. You can create clones on demand and then use it for application development or querying or whatever you need. But business users, they don't use SQL or anything like that. With Dataflix, we will open up a spreadsheet way of accessing data. The user will be able to say, okay, this is a snapshot. Show me what does it contain? Like they might need some high-level information, like how many customers are there, were in last month, and maybe compare data from 2 snapshots. Like last month, how many customers? This month, how many customers? How many new accounts are opened? You'll be able to do a lot of data stat comparison. And then you decide, oh, this data point looks good. You'll be able to say, okay, show me this. And in form of spreadsheet, we will be able to do that, right? Then you can run your own reports, do your analytics, all those things they will be possible. And the last, we know that everyone has to coexist, right? So we also coexist. You can bring any of your third-party service that you use today, like to use Datadog for monitoring, or you use Sumo Logic for logs, right? You can bring that as first-class integrations. Okay, so you can bring your security if you are using JSON, or you can bring that. Tessell can integrate with any of your third-party services. I'll pause for a question if there is any. Otherwise, I'll show a quick demo here. That's been a very common question today. Not today. We are still young. We just went live last year. Cloud is our focus right now. But it's on the roadmap, I won't say near-term roadmap, but once we have mastered the art of cloud, once we've matured on the cloud, then we'll look at on-prem solution as well.
Hi. Regarding the masking, I have a couple of questions. When you say masking, is it just masking the data, or are you encrypting it? And the second...
Okay, I'll answer that. Yeah. So masking is just masking. Data is always encrypted at rest with Tessell. And you can bring your own keys as well. By default, Tessell has out-of-the-box keys, right? But you can bring your own keys. It's always encrypted. You can do database level encryption as well, like TDN or if you want. Masking is more about the data itself. If you are giving the data, let's say you are querying the data, you might have some PII information, let's say a credit card number or phone number, which you want to mask or obfuscate. That's what masking is.
Okay. And what about the performance? Do we get any performance issues when we do the masking and retrieval? And
during masking, you mean? No, you do not. So again, you can't touch your primary database for masking. Otherwise, you will corrupt the actual data, right? So you can't do it that way. The way masking happens is you pick a snapshot and say mask it. That's all you'd have to do, right? And Tessell will take care of creating a copy of the snapshot, which is sanitized, it's masked. So there is no impact on the database at all. It's touchless.
Thank you.
Yeah, so the only thing we ask from the customer is you give your script, right? You like a SQL script or anything like that, that needs to be masked. Sorry? Yeah, DDL can work. And then we can use that to create a copy of the snapshot, which is masked. One of the apps we want to build in the future on the roadmap is sensitive data discovery, where Tessell will be able to tell you, that suggests that, okay, this column looks like sensitive data. You may want to mask it. Does it answer the question? Or I think. Okay, we can take it off. Looks like we're, yeah. Any other? Do we have time or? 5 minutes? Okay. Yeah. Yeah, so it's a replica. It's a replica. It's a live replica of log replication, and we use native technologies. Right, it's not storage-based replication or anything. It will be a Postgres native. We will use open source technology to create a replica on other region, other AZ, wherever you want, and we'll qualify it as a DR replica. So then, if there ever a region goes down, an instance goes down, you'll be able to fail it over.
That's the regular replication.
Sorry?
That's the regular replication. No?
Redo log, you did say?
That is a regular replication.
Regular.
Yeah.
That's we are using database ready.
Yeah.
Yeah.
It's across the region, and so we support both in fact. So one is a live replication where a async instance or a read replica is there.
Yeah.
Other thing is a snapshot replication. For example,
Yeah. You will ship the snapshots.
or a
Yeah.
team sitting in another region, right?
Yeah.
And you want to give them one snapshot access. So those can be all policy based, and these guys can then using the Databricks app can consume and create new copies of it. That's the both kind of replication.
We actually did a big long workshop yesterday, 3-hour workshop on specifically a lot of on BCP and DR. Yeah. So let me, since we probably have 2 minutes, just wanted to give you a glimpse of the Tessell portal. Sorry. Yeah. Go. All right. So the entire Tessell service is built in terms of apps. Okay? And eventually we want to build like device apps also, like iPad apps, where you can just open the app and provision database very easily. But I'll go to one of the apps here, provisioning. You can pick the engine of your choice, right? Postgres, let's say, and you can pick any version that you like. You can pick any cloud, AWS, Azure. That's what we've been talking about, choice of cloud. And then you have the choice of compute, which you talked about, the high performance and standard. So let's say you want to pick 8 vCPU. That's been our theme in this talk, 8 vCPU shape. This is what you get, at about almost a terabyte storage. But as I was telling you, there are like 4 options. You can pick anywhere from 1 terabyte to 4 terabytes. Look at the IOPS, you get 200,000 IOPS, right? If you were to go to 96 CPU, let's say, these are really big machines, you can go to 2 million IOPS. That's what we are talking about, Nitro boost, right? And then I'll go to quickly show you a provisioning. You can pick a network, configure IP addresses for whitelisting. You can generate password or options, parameter, regular stuff. Yeah, you can create a standby, which is a multi-AZ HA or cross-region DR. We talked about that as well. It's a fully managed service, so maintenance, patching, everything is taken care of. You can bring custom scripts if you want to configure it for an application. And then you can define how much data retention you want as per SLA. Now, one of the most interesting, most likable features of Tessell, all this thing I showed you, UI, you can click on this button, code, and it's an API first architecture, so you get an API equivalent. And we even have Terraform providers. So you can download the Terraform code for that UI. You can embed it in your pipeline so that it's very developer centric essentially. Sorry, is there a question? No. Okay, I'll close it. I think I'll stop here. Right? Yeah, this was, there are many other apps. I think we can go in at the booth, but take a pause here and see if there's any question. All right.
Thank you so much.
Is it possible to do a off-cluster recovery given a timestamp? Timestamp I mentioned, not minute seconds. Yeah, minute seconds and microsecond.
Yeah, you mean recovery, right? Recoverability? Yeah, so I didn't go into that. So this is the app I'll show you, Dataflix app. There are a couple of databases here. There's a Postgres database. I'll click on it. And you see, this one has a 35-day data recovery SLA, protection SLA. You can go to any point in time in the last 35 days. So I can even zoom in.
As you see, it does not have a timestamp, right? So you have hours, minute, second. After that, 6 digit is missing.
You mean sub-second?
Sub-second.
Oh, okay, sub-second. So we can actually do, we can go to a transaction level essentially. We can do that. If you because every transaction has a number, right? Like they are called system change numbers. So it's not fully exposed in the UI. These are like really advanced things. But if you really want to go recover to a particular transaction, we can do that. Yeah. Yeah. That will give you your sub-second recoverability. Yeah.
Okay.
So you are saying we have Postgres snapshot, right?
Mm-hmm.
So let's say if any moment I want to change my database, like a data migration, right? From Postgres to MySQL or MySQL to Postgres. Is it possible here?
Do you do that quite often, or typically, generally you do like maybe if you are on Postgres, maybe you fed up with it and you want to MySQL. It's typically a one-time ask. Right?
What happens initially when any company or any developer actually they go with some R&D phase. So actually they set up once in MySQL and later actually they realize that this database is not going to work. Okay, and after that actually they move to Postgres.
Okay.
So there is some data migration process actually it is involved in AWS. They support it actually if you want to change your RDS from MySQL to Postgres, right? So you can do that.
There is no first-class product or feature in the app today, but we can help you with that. So that kind of, there are multiple approaches to it. One of the simple ways to do it is just to extract the data, take the data dump, right? One of the features we have is database dumps. One of the apps that I had mentioned, Availability Machine, where you can export data dumps. It could be a database level, table level, schema level, all those things, right? You can export the dumps, and then we can import it. So that would be one. Maybe we'll have to build a solution around it. Generally, it's a one-time task, right? You don't do it on a recurring basis. So we'll be able to help you out as a solution around it, but it's not a first-class feature in the product as well.
Sure. So, thank you.
Yeah. Yes, that will provide. Yeah. So, yeah. You want to take that?
It's a multi-system we do node by rolling up. If it's unstable, then there will be some backup. It's a single instance.
Yeah. So within the same version, the patching all happens seamless. Upgrade is typically a slightly bigger task, so you have to plan for it, but we'll take care of it essentially.
So what you plan for, like minor upgrade during provision itself, we ask you schedule. So that's that's a downtime kind of schedule that we can take. And if you don't want to upload that, we can also give you on-demand patch. Then today my downtime is going, can you patch that? That's a match. As Bakul said, major one could be a rebooter, but we'll give you all the calculations early. That this is when we can do it. This is what kind of downtime we require on application. But DNS name and everything we don't change. So connection strength and nothing will change. It's always in the same machine. Sorry.
I don't recall any managed service from Nutanix. The only closest we know is RDS. That's what we always talk about RDS. Yeah.
Okay. Thank you. Thank you so much.
Thank you.